Rotational motion is found everywhere in the universe, from spiral galaxies to atoms, from wind turbines to washing machines, and sports players, spin bowling and pirouetting figure skaters. In order to be able to describe this motion, we're going to need to look at a few key terms and their definitions. So here we can see an object describing a circle, and the period of that object is the time it takes to complete one revolution about some axis. The SI unit, because it's a time, would be the second, and an example would be that it takes the Earth 1 year to orbit around the Sun. The usual symbol for the period is a capital T. So now we're going to look at the frequency of rotation. Very similar to the definition of frequency when we were talking about waves. So that's the number of rotations or the number of revolutions per unit time. It has the same SI unit, which is the hertz, and you can calculate the frequency by being 1 over the period. If we do an example, an ice skater completes 4 rotations in 1.2 seconds. What is her frequency of rotation? Well, the period is going to be a quarter of that time, which is 0.3 seconds, and therefore the frequency is 1 over the period, so that's 1 over 0.3, which comes out as being 3.3 hertz. So now we're going to look at the angular velocity and the tangential velocity. So if we have our object moving through an arc, and it will have gone through an angle of theta, where theta is going to be in radians, and it's taken a time t for that to happen, then omega is the angular velocity, which is the rate of change of angle. So it would have the SI units of radians per second. Now, if we were talking about a complete revolution, then the angle would be 2 pi divided by the period, and because the frequency is 1 over the period, omega is also equal to 2 pi f. Now, if we think about the tangential velocity, which is how quickly the object is moving around the circle, then it will have covered a distance s. Because we're operating in radians, that's going to equal theta r, so the velocity is going to be delta s over delta t, which is going to be delta theta r, and over delta t, then delta theta divided by delta t is omega, so the tangential velocity is omega r. So now on to an example. What is the tangential velocity of a point on the equator of Mercury which has a rotation period of 59 days and an equatorial radius of 2,500 kilometers? We know that V is equal to omega r, and omega is 2 pi over the period, so V is 2 pi r over the period, leading to V is 2 pi times 2.5 times 10 to the 6, converting the kilometers into meters, divided by 59 times 24 hours in a day, multiplied by 3,600 seconds in an hour, and that gives us an answer of 3.1 meters per second.